Okay, part three, radical expressions. Now this seems like it's nothing to do with quadratics, but it'll make more sense when we get to the last lesson. But let's review how do you solve square roots. Now you have a calculator. So if I ask you to take a calculator out and take the square root of 25, what you're going to see is 5. The answer for this is 5. Um, now, that is only when the number is a perfect square. If you notice, we have other numbers that are not perfect squares. So when we do that, we have to factor them out. So let me show you how to do it with 28. 28 doesn't have a factor. Now you can guess. It might be 5.1, 5.2, 5.3, right? If you have a calculator, you'll know about, a close number that approximates the square root of 28. But the problem with a calculator is you have to round your answer, which means it's not 100% accurate. So if you put the answer of 5.2, you're approximately correct. You're not 100% correct. So what we're going to do is we're going to write a radical expression that is 100% accurate to the answer. So what we do is we split it up into numbers that actually have square roots. So what numbers have square roots for this? Now, 4 times 7 makes 28, but only 4 has a square root. What's the square root of 4? 7 doesn't have a square root. So this is actually more accurate of an answer than 5.2. So we want the answers to look like this. So guys, unfortunately, if you use your calculators and you put decimal answers, you're going to be wrong. They want you to write the answer in this radical expression. And radical is just another way to talk about square roots. Okay, it's just a square root. All right, so this is what the answer should look like. Now, if you're multiplying them, the rule is you combine like terms. So like the 9 and the 5 will multiply, and the square roots will multiply, but they don't mix because they're different kinds of numbers. So you have 9 times 5 is 45, and you have 2 times 10 is 20. Okay, then you leave the 45 alone, factor the 20. What numbers make the square root of 20? So I think of 4 times 5. Which one of those numbers has a square root? So you take out the square root of 4, which is 2, and the 5 stays behind. Now, here's the weird part. The 45 in front does not change, but now you have a 2 and a square root of 5 along with it. But now that 2 is not a square root anymore. That 2 is a regular whole number. So what do you do with the whole numbers? You multiply them. So 45 times 2, you get 90 square root of 5, and this is the answer. So only the only thing in the square root are numbers that don't have perfect squares, that don't have square roots. Okay? Now let's introduce variables into it. What happens if I have a variable? So here, you already know the 5. 5 comes out, but what about x squared? So I'm going to teach you a shortcut. Whenever you have variables with exponents, because we're dealing with the power of 2, square roots are all about the power of 2. All of them. All of them, all of them. So you can divide your exponents by 2, and that'll tell you how many you can get out. That'll tell you how many come out. So what's 2 over 2? 1. So how many x's can come out? 1x. And now there's nothing left inside. So you just have 5x as the answer. Okay? Now here's a problem. If you do this, it's not going to divide perfectly by 2. But you can still take out one of them. So we'll go into that. Let's start with the 24 though first. Let's take care of the numbers first. What makes 24? We already talked about this. 4 times 6. Square root of 4 is 2. So you take out the 2. So you get 19 times 2, square root of 6, x to the third power. 19 times 2 is going to be 38. Yes, 38. Sorry, I was just double checking. Now for the shortcut. Remember, power of 2. If you divide this by 2, how many x's will you be able to take away? 1.5. What? Yeah, you can't take away a half. How many whole x's, how many whole numbers is there? 1. So you can take out 1x, But because you get a half, that means there's a remainder inside. So guys, if you couldn't take out all the x's, you just leave behind one x. If you leave behind an x, that shows that there was not everything came out. Not everything could be taken out. There was a remainder, and that was left inside the square root. Okay, so that's my shortcut. Okay, here, multiply this. Again, you're going to do the whole numbers first, so 7 times 3. Then inside the square roots, we'll do 5 times 15, and we'll do x times x squared. Whew. Okay, so we get 21, 50, 75, x to the third power. Now for 75, that's 25 times 3. Okay, so if you take the square root of 25 times 3, the square root of 25 is 5. So you get 21 times 5, 3x3. All right, we're almost done. That's 105 on the outside, but we haven't dealt with the x's. So we divide that by 2. How many x's come out? 1 x comes out. How many are left inside? A remainder of 1. And that's my answer. Okay, so I know it's kind of new. It's weird. Watch these slower if you have to see every step that I do. I'm going to do one complicated one just to show you and kind of finish off the notes. Okay, what if we get this? Okay, so the numbers outside combine. So 4 times 3x. The numbers inside combine, 3 times 12. And then we got to do x squared z times yz to the 4th. Sorry, that looks really weird. I apologize for that. Okay, so let's combine our numbers first. Let's do 12x square root, much better, 36. Now, yeah, let's talk about what happens with all these things. Well, there's no x inside, so x is going to remain unchanged. But now we have a z and a z to the 4. Z times z to the 4 is going to be z to the 5th. Oh, but there's a y too. The y is not going to combine. The y will just be left alone. So you have a bunch of variables in here. All right, now 36. Actually, 36 has a square root. The square root of 36 is 6. So I'm going to take out the 6 to join the 12x, and then we'll deal with this in a second. We'll deal with this in a second. Right here, that would give me 72x. All right, let's deal with our exponents now. Now, the shortcut is everything is divided by 2. Now, there's no exponent there. Yes, there is. A 1 divided by 2. Divided by 2. Okay. How many x's can we take out? 1 more x. Okay, so we can take out 1 more x. Comes out. There's not enough to take out a y, so you're going to leave a y inside. What about the z? 2 z's. Z squared. Oh, but it's not a perfect. There's a 1/2 remainder. 1 z stays inside. So, let's not forget, this is what I took out. What's still in front is that. What do you do with these? You put them together. Well, there's only 2 things that match. You're right. So you're only going to combine x times x. So you're going to get 72x squared, z squared, root y, z. And yeah, this is probably the most complicated problem you'll see for these, where you have to just be very careful with each term. Each term has to have its own attention to focus if it has a perfect square that can come out or not. Okay, but yeah, that's it.